and I would love to talk about ultra-stable functional end-to-end monitoring in production. Specifically, how we use AI to make sure that you have exceptionally stable functional end-to-end tests. We will be talking about specifically web and mobile testing and monitoring, and not API, IoT, and so on and so forth. First of all, I would love us to get to the first principles and think about what is the goal of monitoring in production. If you think of it from business perspective, then we believe that it is making sure that the functionality in production works for your end users and allow them to execute their business functions as they would expect. Well, this is not exactly how we monitor things sometimes. If we only monitor API, we might not necessarily achieve that goal. Let's talk about how we can do that. We already have Selenium, aren't we? What's the problem? Well, it's a little bit of a challenge, as you can think. It's not that simple to even start writing Selenium tests. You have to set up your environment. You'll have to maintain your environment because Chrome will auto-update, and you would need to update Chrome driver almost every other day in order to catch up. And it is quite an effort to write tests, so much so it will probably take you a year to create 100 stable tests in Selenium. And at some point, test maintenance on those tests will be so huge, it'll become your full-time job. Doesn't sound like a good perspective, isn't it? It's not even all of that. Think about it. What currently people are doing for end-to-end monitoring? Well, oftentimes we don't just do it. We stick to API testing because we can't make it work with Selenium. And what does it mean is that you basically don't know what's going on in production. Next is little automation with Selenium Appium, but that requires ginormous amount of maintenance. 5% of tests is always breaking. You actually can't have enough tests in there, just barely a little bit, because of this problem. High cost of creation maintenance, and it's exceptionally slow to create. But most importantly, 5% of all Selenium tests always break. So that is average statistics. In a lot of cases, actually more than that. Sometimes it's less, but it's always a certain percentage. What does it mean? But it means that basically not applicable to end-to-end monitoring. All right. Why is that, and how testRigor helps in this particular case? testRigor helps in two ways. testRigor is a way where you can write your tests in plain English, and testRigor will execute those tests, emulating how a manual tester would do that, or how your end user would do it, for that matter. This is basically makes it far less code to write compared to Selenium. We can compare Selenium code on the left and testRigor code on the right. It's pretty obvious. Plus, it is not reliant on details of implementation. Probably the largest problem with Selenium is that it relies on details of implementation, such as IDs, names, XPaths, and so on and so forth. So basically, what's happening is that if you hooked up your tests into details of implementation of how exactly the page is implemented, when anytime engineers change the implementation of the page ever so slightly, the test will break, and therefore notifying you in the middle of the night as something is broken after the deployment, and it will be false positives. That is not what you want to do. You want to be able to reuse tests which maybe your product owners created themselves, and they're being propagated to production and reused for monitoring, because they are not relying on details of implementation, therefore we just don't need to be updated. And therefore we do not break for no particular reason. Maintenance is actually a ginormous problem. Because of this issue, this reliance on details of implementation, usually what we see is it becoming a full-time job to just maintain tests at around 350 tests per person on average. Think about it. Is test maintenance something you'd like to make your full-time job? I don't think so. All right, so let me show you a little bit of a demo. So this is how tests look like in testRigor. As I mentioned, plain English, validations, clicks is relative locations, entering data, and you can group your steps into functions and give them arbitrary names for readability. You can do it in advance or post factum with refactoring. Everything that you would expect. So, however, the most important part is how testRigor execute your tests. Of course, you can say things like click communication preferences and the product into search products, but you can also do things like enter test into first name, enter rigor into last name, where first name and last name are technically some random text which are might not be technically anyhow related to respective inputs below. It's just for us humans, those texts indicate that you should enter first name into input below and last name into input below last name. However, tomorrow those texts might be on the left of those inputs. Day after tomorrow, they might be placeholders like in input above. For us humans, it is all the same thing, right? You still are able to do exactly the same thing, because from humans' perspective, it is still first name input, last name input, no matter how those texts are placed, or if it's a placeholder now, and so on and so forth. testRigor works exactly the same way. It emulates how humans do it, as opposed to how you would code it from engineering perspective. Therefore, make it as stable as the specification itself. And of course, you can deal with multiple elements, saying things like click update in change your password section. And voila. So this is how testRigor helps our customers to have ultra stable functional monitoring in production using executable specifications in English. Thank you very much.